Okay, this next section, section 4, it doesn't really have any new material in it. It's really more of a shortcut, so I think you'll like this. Let's jump down to the bottom. We're going to do a quick proof to kind of prove the theorem, and then show you what the theorem is. So in this case, it's given that AM is congruent to AN. It's a median, so that means these two are congruent to each other. You got a reflexive, so that means the triangles are congruent to each other, which then gives you these two by CPCTC. Okay, so if I wanted to write this out, I would basically go ahead and prove the triangle is congruent by SSS, and then of course I got a CPCTC step from that. And what this proof actually proves is the theorem. So it's basically saying that, okay, if I have a triangle and I'm given that these are congruent to each other, then I can prove that the base angles are congruent to each other. Okay, and what we're going to find is that this is reversible, so therefore this is also true. And what it does is it sort of cuts out the step of, in some of the proofs in the last section, we would be given something as, we'd be given that you have a sides are congruent, and then you'd have to go and say that it's isosceles. And then from there, you'd have to say it's isosceles, so therefore the base angles are congruent to each other. So here you can skip this isosceles portion and just go straight to using one of these. Okay, so let's actually use it in a couple of proofs on the back side here. Okay, we're now moving to the back side of this thing, looking at proof number 2. And I know that OP is congruent to RS. And I know that KO is congruent to KS. And what we're trying to prove here is that MP is congruent to TN. So this we're trying to prove is this segment is congruent to this segment. Hopefully you can see that. What we really need to do here is get that these two triangles are congruent to each other. The other piece of information we have here that's kind of nice is we have this midpoint and this midpoint right here, two midpoints. So I'm looking at probably division or multiplication properties in order to solve this thing. And in this case, because M is the midpoint and T is the midpoint, and I have these green segments congruent to each other, I know that these must be congruent to each other by division property. I'm starting big and I'm concluding small. And so that's the division property. And from here, I have two pieces, right? I have these two sides congruent, and then I need one more side, and that's where we're going to use the theorem from this section, where if you have if sides, then angles congruent. And so that'll give you these bottom angles there and there congruent to each other. Okay, so let's write this out. Step 1, OP is congruent to RS. That's just giving you this one of the sides. Step 2, I know that KO is congruent to KS, and I know that M is the midpoint, and I know that of OK, and I know that T is the midpoint of KS. Okay, I am going to put all these as a given together because I know I'm going to use all that to come up with my third step, which was using the division property MO is congruent to TS. So my step 3 here, MO is congruent to TS, that's going to be by division property. And I am almost done here, getting all the information I need. I can go from here now and get step 4 and say that angle O is congruent to angle S. And we said that that's because if sides are congruent, then the angles are congruent, the base angles. And then I can now say that the triangles are congruent to each other. So triangle MOP is congruent to triangle TSR by side angle side. from steps 4, 3, and 1. And then CP/CTC it at the end there, so I know that MP is congruent to TR by CP/CTC. Okay, let's try one more problem. Let's try the proof down at the bottom here, proof number 3. Okay, it starts out with isosceles with a vertex angle of B. So I know like these sides are congruent, and I know that the base angles are congruent to each other. And I know this is isosceles here, so that means that this is congruent to this, and that these base angles are congruent to each other. And I'm trying to prove that this is congruent to this. And it looks like I have some useful pieces already here, right? If I take just this big green angle and subtract the red one, I can get that this angle is congruent to this one by subtraction. And I know that this is congruent to this because they're vertical angles, and so I can get those triangles congruent. So let's go ahead and write this out. Step 1, I got my isosceles steps, so I'm going to put that in there. Again, on test or quiz, write that out, please. Step 2, I need, what do I need here? I need the base angle is congruent. So angle DAC is congruent to angle ECA. And that's because if isosceles, which is what we have in the first step, then I know the base angles are congruent. I can also say that, same thing here, I'm going to say that angle FAC is congruent to angle FCA for the exact same reason. If isosceles, then the base angles are congruent. Now I can do a subtraction property, so angle DAF is congruent to angle ECF by subtraction. And step 4 here, I can say that FA is congruent to FC. FA is congruent to FC. I can say that because it's isosceles, or I can go ahead, if I want, just for laughs and giggles, I can say that if the base angles are congruent, then the sides are congruent. Either of those reasons would have worked. And then I got the vertical angles. So angle DFA is congruent to angle EFC because they're vertical angles and they're congruent. Vertical angles are congruent. And then step 6, I can say the proof statement, and the reason is going to be by angle, side, angle, 3, 4, and 5. Okay, I think you'll get better at using this theorem, this one right here. Trust me, it does come in handy. You'll end up using this quite a bit. So practice it on the homework. All right, good luck.